Hi everyone, today I'm going to teach you about a little thing called empirical formula. So simply put, empirical formula is the simplest ratio of atoms. You used to have to calculate this, but now in this spectroscopy standard, you're simply going to need to know how to use the empirical formula. I'm going to abbreviate empirical formula to EF. Okay, so the empirical formula is the simplest ratio of atoms. So I think the simplest way to do it is just to show you an example. So you will be given an empirical formula. So let's say, for example, our empirical formula is CH2. So this is the simplest ratio of atoms. So we've got one C for every two hydrogens, right? One carbon for every two hydrogens in this formula. But we know this can't be the actual formula. The actual formula has to have, each carbon must make at least 4 bonds. So we know this can't be right. But what we do know is that the actual formula, or the molecular formula, is going to be some kind of multiple of the empirical formula. Okay, so i.e. we're going to take this and we're going to multiply it by 2 or 3 or 4 or 5. Okay, so for example, if we multiplied it by 2, right, we would get 2 C's and 4 H's. Now that looks more like a molecule that could exist. Right, if we take that and we multiply it by, just do it like this, another 1, so we multiply it by 3, we would get 3 C's, and 3 times 2 is 6 H's. And if we multiplied it from the start again by 4, we would get 4 C's and 8 H's. So these are some of our smallest possibilities for our actual formula. This one is not possible. We cannot have a molecule that's CH2. So how do we know which one's right? We actually need to find a way to find out what the molecular formula is, the molar mass of the actual compound. So the molar mass will be given to us. So if the molar mass was for C2H4, if this was the correct molecule, then our molar mass, let's just put these down here, for this would be 2 times C, so that's 2 times 12 plus 4. So that's 28, and I'm just going to put the units down there. The molar mass of this would be 3 times 12 plus 6, so that would be 42. And the molar mass of this would be 4 times 12 plus 8, which would be 56. And notice again here that what we've got, we work out the molar mass of this original, so it's 12 plus 2 is 14. If we multiply 14 by 2, we get 28. If we multiply 14 by 3, we get 42. And you can see the pattern. If we multiply it by 4, we get 56. Right, so let's just say, for argument's sake, that we were given 56 grams per mole as our molar mass. So the question would say the empirical formula is CH2, and somehow, we'll learn this later, we know that the molar mass of the actual substance is 56 grams per mole. So what we would do is we would go, okay, I can work out that the formula mass for this is 14 grams per mole. And I know that my actual molar mass is 56. So 56 divided by 14 would give us 4. And I therefore know I have to multiply CH2 by 4, which will give me C4H8. Okay, so I've used my molar mass and my empirical formula to work out the actual formula of my molecule. This is the first step, and then the next thing we need to do is we need to now consider isomers with the formula C4H8. Now, an important thing to notice here is that because the number of hydrogens is exactly double the number of carbons, there must be a double bond in there. If we started to just do 4 carbons, 2, 3, 4, and started to put our hydrogens on, 1, 2, 3, 4, 5, 6, 7, 8, you can see straight away that this poor little carbon hasn't got enough hydrogens, so obviously we actually need to stop there and redraw. 3, 4, put a double bond in somewhere, 1, 2, 3, 4, 5, 6, 7, 8. Right, so it's something with a double bond in it. So this here I've quickly drawn is the most obvious and simple answer, which is butanene. But if you're very good at organic chemistry, or even a little bit good, you would figure out that it could also be butene. If you're still remembering your level 2 chemistry, you would also remember that this could be cis and trans, but we don't need to know that. And those of you who are really thinking would realise that it could also be, I'm going to have to go up here, a alkene with a methyl group. So if I put my little double bond in there, 1, 2, that's it, one there. Okay, this is methyl propene. And I don't need any numbers there, so hopefully you can figure out why. And I actually do not think that there is any other version of this. So at this stage, we know that if we have an unknown molecule that has an empirical formula of CH2, a molar mass of 56, we know its actual molecular formula must be C4H8, and there are 3 possible isomers of it.